Hello and welcome to Grace Tutorial. In this video lecture, we will be discussing about one of the most important chapters of 10th Standard Science CBSE, that is acids, bases as well as the salts. In the first step, let me give you a brief introduction about this chapter. Well, let us commence the chapter beginning with elements. What do you mean by elements? Elements are the pure substances which are made up of only one type of atoms. That means they are the basic unit of all types of the matters. These elements combine together in a fixed ratio to form the compounds. So what do you mean by compound? A compound is a substance which is formed by the union of two or more elements, or by the union of two or more substances. Let me give you some of the examples of the compounds so that it will be easy for you to understand. Suppose the hydrochloric acid is a compound, because this compound is a substance which is formed by the union of hydrogen as well as the chlorine. Similarly, we have H2SO4, sulfuric acid. Well, the sulfuric acid is also a compound, and it is also formed by the union of hydrogen, sulfur and oxygen. That means a compound is a substance which is formed by the union of two or more elements. Well, these compounds have been classified into three distinct classes. Those are acids, bases as well as salts. Now the question is, how the acids and bases can be identified. Let us try to understand the identification of the acids and bases. Well, the acids can be easily identified by their sour taste, whereas the bases can be identified by the soapy touch or by the bitter taste. Well, you need to remember here that all the acids cannot be tasted or even touched, because some of them may harm the body. And salt is a product which is formed by the combination of acids and bases. As I just said you, all the acids cannot be tasted and all the bases cannot be touched, or it cannot be tasted even, because some of the acids as well as the bases may harm the body. So what is the best way to indicate, and how can we recognize the acids as well as the bases? Well, then we have two factors, that is indicators as well as the characteristics chemical reactions. That means the acids and the bases can be recognized by the indicators as well as by their characteristic chemical reactions. Now what is this indicator? An indicator is a chemical that indicates by means of a sharp change in color or the nature of a solution. Now let's try to understand. There are two great scientists, the Lavoisier and Davy. The Lavoisier and Davy studied about these three terms, that is acids, bases as well as the salts, and their findings say that all the acids compulsorily have hydrogen as their constituent element in the form of hydrogen, in the form of proton. That means the substance which is acid compulsorily possesses the proton. So here the Lavoisier and Davy findings say that all the acids compulsorily have the hydrogen as their constituent element in the form of proton. For example, the hydrochloric acid, it possesses the proton, and in sulfuric acid, the sulfuric acid also possesses the proton. Similarly, the nitric acid also possesses the proton. So it is very clear that all the acids possesses the proton as their constituent element. And what all are about the bases? All the bases are either metallic oxides or metallic hydroxides or ammonium solution. For example, the copper oxide is a metallic oxide, the sodium hydroxide is a metallic hydroxide, and the ammonium hydroxide is an ammonia solution. So this is all about the bases. These are the examples of the bases. Now let us discuss what is salt and what are the examples of salts. So what is this salt? Well, it is a chemical compound which is formed by the combination or the interaction of the acids as well as the bases. So what are the examples of the salts? The sodium chloride is a salt which is formed by the combination of acid as well as the bases. Similarly, the calcium chloride is also a salt and ammonium phosphate is also a salt. So this is all about the salt, and we will discuss about the salt very broadly with slightly later. Now let's try to understand what does the term acid exactly refer to. Basically, the word acid has been derived from a Latin word that is acidus, which means sour. In fact, some foods are sour in taste due to the presence of the acid. So let us have a look at some naturally occurring acids. Well, acetic acid is present in the vinegar. The citric acid is present in the citrus fruits like lemons or oranges. Similarly, the hydrochloric acid is present in the gastric juice. The malic acid is present in the apples, and the oleic acid is present in the olive oil. So this is all about some naturally occurring acids. Now we will discuss the definition of acids. If we look at the definition of acid, then what is the definition? Acids are defined as the compounds which contain one or more hydrogen atoms and when dissolved in water produce the hydrogen ions, that is H3O plus ion, the only positively charged ions. So it's very simple to define, my dear students. These are the compounds and it contains at least one or more hydrogen atoms. But when these are dissolved in the water, then that will be converted into the H3O plus ion, that is the only positively charged ions. Let's look at some of the examples. Well, we have hydrochloric acid, and when this hydrochloric acid is dissolved in the water, then it furnishes a proton, that is H plus, and the Cl minus will be removed. Well, but this proton cannot exist independently. So what it needs to be done? The proton, it reacts with the water molecule to form the hydronium ion. Now this hydronium ion can exist independently. Once again, I just repeat this point. The hydrogen chloride or the hydrochloric acid, when it is dissolved in water, it furnishes or splits into H plus or Cl minus. That means this proton cannot exist independently in the aqueous solution. So what it needs to be done? It reacts with the water molecule to form the hydronium ion. Now this hydronium ion can exist independently. Let us look at some more examples of the acids. Well, we have sulfuric acid, nitric acid as well as the acetic acid. When the sulfuric acid is dissolved in the water, then it gives the 2 hydronium ion along with the sulfate ion. Similarly, when the nitric acid is dissolved in the water, it gives 1 hydronium ion along with the nitrate ion. Similarly, when the acetic acid reacts with the water, it gives 1 hydronium ion as well as the acetate ion. Well, these are the various examples of the acids. Now let us have a look at the classification of acids. So if you look at the classification of acids, the acids have been classified into various categories. Well, depending on their sources, if you look at the first point, depending on their sources, the acids have been classified into 2 categories. Those are organic acids and inorganic acids. So what do you mean by the organic acids? The acids which are usually obtained from the plants. Well, the acids which are usually obtained from the plants are known as the organic acids. So what are the examples of the organic acids? Well, we have oxalic acid, that is COOH, O2, acetic acid, CH3COOH, formic acid, HCOOH. All these acids are the organic acids because these acids are obtained from the plants. And you need to mention one more point here, that these acids contain both the carbon as well as the hydrogen. That means the carbon and hydrogen are the most important elements in these acids. And these acids are weak acids because they do not ionize completely in the aqueous solution. And these acids contain ions as well as the molecules. Well, that's all about the organic acids. Now let us have a look at another point too, that is inorganic acids. So what do you mean by these inorganic acids? These inorganic acids are also known as the mineral acids. Well, inorganic acids are also known as the mineral acids. Why? Because these acids are obtained from the minerals. So which are the acids obtained from the minerals? Let's have a look. We have hydrochloric acid HCl, we have sulfuric acid H2SO4, we have nitric acid HNO3. And all these acids are obtained from the minerals. That's why these acids are also known as the mineral acids. And these acids do possess only the hydrogen atom but not the carbon atom. But there is one acid which do possess the carbon atom in the inorganic acids, that is the carbonic acid, that is H2CO3. So H2CO3 means the carbonic acid. This acid contains the carbon. Though it contains the carbon, it comes under the inorganic acid. So if you are asked the question that what is the name of that acid which possesses the carbon and it comes under the inorganic acid, means you have to immediately say that the carbonic acid. Well, this is all about the examples of the inorganic acid. And you need to remember here that the inorganic acids, that means these acids are the strong acids. That means when they are dissolved in water, they ionize completely in the aqueous solution, and here they contain only the ions. That means these organic acids contain the ions as well as the molecules. The organic acids contain the ions as well as the molecules, whereas the inorganic acids contain only the ions. So this is all about the inorganic acids as well as the organic acids, and these two acids are on the basis of their sources. So depending on their sources, the acids have been classified into two categories. One is organic acids and number two the inorganic acids, and that's what all about we have discussed. Now let us go for the point number 2. Now, depending on their basicity, the acids have been classified into various categories. So first of all, we need to understand what do you mean by this basicity? Because if you do understand the term basicity, then all these things can be easily categorized. Well, the basicity of an acid is defined as the number of hydronium ions, that is H3O plus ion, that can be produced by the ionization of one molecule of that acid in the aqueous solution. This is the definition that I have written for you. I think it's better that you note down. Also, the basicity of an acid is defined as the number of hydronium ions. That means whenever the acid dissolves in the water, the number of hydronium ions that is produced by that acid is what basically called the basicity. So on the basis of their basicity, the acids have been categorized into the various types. First of all, we will discuss what do you mean by this monobasic acids. Well, whenever the acid, after dissolving in the water, produces only the one hydronium ion, then that comes under the monobasic acids. Let us take some of the few examples of the monobasic acids. We have hydrogen chloride or hydrochloric acid. When this hydrochloric acid reacts with water, what happens? One hydronium ion is produced along with the chloride ion. So the various examples, similarly, the various examples of this monobasic acids are hydrogen bromide, nitric acid, hydrogen iodide, acetic acid, etc. These are the various examples of the monobasic acids. That means when these acids react with the water, then only the one hydronium ion is produced here. The one hydronium ion is furnished here. So that is what basically called the monobasic acids. And you know, these monobasic acids, it ionizes only in one step. So when it reacts with a base, then it immediately gives a normal salt. So that's all about the monobasic acids. Now let us discuss the dibasic acids. So if we look at the dibasic acids, whenever the two hydronium ions are furnished, when that acid dissolves into water, then those acids are called the dibasic acids. For example, the sulfuric acid is a dibasic acid, the oxalic acid is a dibasic acid, or sulfurous acid is a dibasic acid, and carbonic acid is also a dibasic acid. So these are the acids which comes under the dibasic acids. Dibasic, let us take some of the few examples. Well, we have sulfuric acid. When the sulfuric acid dissolves with water, what happens? In the first step, it gives the hydronium ion along with hydrogen sulfate. And that hydrogen sulfate, again in the second step, dissolves with the water to give the hydronium ions. That means here the two hydronium ions are formed in this acid. So whenever an acid dissolves in the water, if it produces the two hydrogen ions, then that is what basically called the dibasic acids. Let us take one more example so that it will be easy for you to understand. We have H2CO3, carbonic acid. When this acid reacts with water, we have hydronium ion along with hydrogen carbonate. Once again, in the second step, when this hydrogen carbonate reacts with water, it gives another hydronium ion as well as the carbonate ion. That means here, the two hydronium ions are produced. That means, when the acid dissolves with water, it ionizes into two steps. It ionizes with two steps. So, when it produces the H3O plus ion, two H3O plus ions, then we can easily say that it comes under the dibasic acid. But you need to understand here, you need to remember that dibasic acids have the capability of replacing the two hydrogen atoms. That means these acids can replace the two hydrogen atoms. Therefore, they can form the two different types of salts. One is the acid salt and number two the normal salt. Whenever the sulfuric acid reacts with the sodium hydroxide, then what happens? In first case, it forms the sodium bisulfate or sodium hydrogen sulfate, which is an acid salt. And in the second case, when the sulfuric acid dissolves with it reacts with the sodium hydroxide, it gives the sodium sulfate. So the sodium sulfate is basically a normal salt and the sodium bisulfate is basically an acid salt. That means, since it is having the capability of replacing the two hydrogen atoms, that's why it can form the two different salts. One is the acid salt as well as the normal salt. So that's all about the dibasic acids. Now let us discuss the tribasic acids. Here let us try to understand the tribasic acids. So what do you mean by this tribasic acids? When the acid on dissolving with water produces the three hydronium ions, then that acid is what basically called the tribasic acids. Let us take some of the examples of the tribasic acids. Phosphoric acid, citric acid, etc. comes under the tribasic acids. Let's have a look. Well, we have H3PO4, that is the phosphoric acid. When it reacts with water, and in the first step, it ionizes to give the H3O plus as well as H2PO4 minus. And in the second step, this H2PO4 minus reacts again with water to give the H3O plus, that is one more hydronium ion will be produced along with HPO4. And when this HPO4 minus treats with water, it gives one more hydronium ion with phosphate ion. That means this phosphoric acid ionizes into three different steps. It ionizes into three steps to form the hydronium ions. Well, so that's why, since it is producing the three hydronium ions, therefore it is known as the tribasic acids. So this is what we have written the example of the tribasic acid, that is all about the phosphoric acid. Now let us try to understand. This tribasic acid is basically can replace the three hydrogen atoms. And since it is having the capacity or the capability of replacing the three hydrogen atoms, it can form the two acid salts, two different acid salts as well as the one normal salts. Let us have some examples of this. Whenever the phosphoric acid reacts with the sodium hydroxide, it gives the monosodium dihydrogen phosphate, that is NaH2PO4 with the water molecule. Similarly, when this H3PO4, the phosphoric acid, reacts with the two molecules of the sodium hydroxide, then what happens? It gives the disodium hydrogen phosphate, that is Na2HPO4. And the next one, we have when the phosphoric acid reacts with the three molecules of the sodium hydroxide, it gives the trisodium phosphate. That means, since it is having the capability of replacing the three hydrogen atoms, that's why it can form the two different acid salts as well as the one normal salts. These are the two different acid salts and this is one of the normal salts. So that's all about the tribasic acids. Now we will discuss the preparation of acids. Now let us discuss the preparation of acids or the methods of preparation of acids, that how the acids can be prepared. So far we have discussed that what does the term acid refer to and what is the definition of the acids, what are the various examples of the acids, and we also classified the various acids, that means the classification of the acids. Now let us try to get the preparation of the acids. The first method is by synthesis. Look at here, by synthesis means whenever the hydrogen atom, whenever the hydrogen reacts with a non-metal, then what happens? The acid produces. This is what called the biosynthesis. That means when the hydrogen reacts with a non-metal, then it gives one more substance that is an acid. So look at here, these are the examples given for you. When the hydrogen reacts with chlorine molecule, it gives the hydrochloric acid. Similarly, when the hydrogen reacts with bromine, it gives hydrogen bromide. Or when the hydrogen reacts with sulfur, it gives the hydrogen sulfide. So these are the various acids which is formed by the synthesis of two substances. The method number 2. What is this method number 2? By the action of water on non-metallic or acidic oxides. That means these are the acidic oxides, and when these acidic oxides are reacted with water, what happens? These acidic oxides react with water to form the H2SO4, that is the sulfuric acid. Well, this H2SO3 and 1O, that is H2SO4, that is sulfuric acid. That means when the sulfur trioxide reacts with water, it gives the sulfuric acid, and this sulfur trioxide is an acidic oxide. The name of this product is sulfuric acid. Sulfuric acid. Similarly, when the sulfur dioxide reacts with water, it gives H2SO3, that is sulfurous acid. Similarly, when the carbon dioxide reacts with water, it gives carbonic acid. That means the acids can be produced when the acidic oxide reacts with water. We have some few examples, such as P2O5, the phosphorus pentoxide. And when this phosphorus pentoxide reacts with the 3 molecules of the water, then we get phosphoric acid, that is H3PO4. Similarly, when the dinitrogen pentoxide reacts with water, then we get the nitric acid. That means from this second method, what do we really need to understand? That when the acidic oxides react with the water, then it gives acids. So that's all about the method number 2. Now we will move on to the method number 3. Let us try to understand the third method of the preparation of acids. What is the third method? By the oxidation of non-metals. That means when the non-metals such as sulfur, phosphorus, right, when the non-metals, it reacts with the acids, the nitric acid, when the non-metal like sulfur reacts with the nitric acid, it gives the sulfuric acid, the water as well as the nitrogen dioxide, NO2, nitrogen dioxide. Similarly, when the phosphorus reacts with nitric acid, it gives phosphoric acid. That means the non-metals such as sulfur and phosphor reacts with the acids to give the sulfuric acid as well as the phosphoric acid. That's what we need to understand from this method. If we look at the fourth method, then what is this fourth method? By the displacement. And the displacement I had already explained to you in the first chapter, that is the chemical reactions and equations, that we had discussed the various types of the chemical reactions such as combination reaction, decomposition reaction, displacement reaction, double displacement reaction. So what do you mean by this displacement reaction? Displacement reactions are the reactions in which one atom can displace the another atom. So here, similarly, which is that atom can displace? This is basically a less volatile. These acids are the less volatile acids. So these less volatile acids can displace the volatile acids. That means here the acids are formed. Acids are formed by the displacement of the volatile acids by the less volatile acids. So for example, we have when the sodium chloride reacts with sulfuric acid, we have got the sodium bisulfate, that is NaHSO4. So what's the name of this NaHSO4? Sodium bisulfate. And how the sodium bisulfate is formed? When the sulfuric acid reacts with NaCl, sodium chloride. That means the sulfuric acid, due to its less volatile in nature, this less volatile can displace, or since it is less volatile, it can displace this NaCl, which is the more volatile in nature. Similarly, when the sodium nitrate reacts with the sulfuric acid, then what happens? It gives the sodium bisulfate with the nitric acid. Similarly, the sodium bisulfate with the hydrochloric acid. That means the hydrochloric acid as well as the nitric acids are formed when the less volatile acid reacts with a volatile product, a volatile formed product. That means when the less volatile substance reacts with a volatile substance, then what happens? It can easily displace. That's why it comes under the displacement reaction. So we have got the hydrochloric acid as well as the nitric acid. This Na, the sodium has been removed. That means the sodium has been moved to this H2SO4. That means the H, it has been reacted with the Cl and it forms the HCl, and NaHSO4 has been formed here. Similarly, the one hydrogen atom of this hydrogen sulfuric acid, it reacts with the NO3 so that it becomes the nitric acid, and we have NaHSO4, that is sodium bisulfite. In this way, by the displacement reaction, these two acids are formed. So that's all about the method number 4, that is by the displacement reaction. So far we have discussed the methods of the preparation of the acids. We have discussed the various methods starting from by synthesis to by the displacement reaction. So that's all about the methods of preparation. Now we will discuss the properties of acids.